All right, let's talk about one of the biggest shifts happening in the crypto world. It's a technology called proof of stake, and it's trying to solve a problem so massive it can make or break the future of these networks, their gigantic energy footprint. Let's get right into it.
So picture this. You have a global system that anyone can use, but nobody, no company, no government, no CEO is in charge. How on earth do you all agree on what's true? How do you stop people from cheating the system? This right here is the core problem that every single decentralized network has to solve.
The answer is something called a consensus mechanism. Honestly, you can just think of it as the network's rulebook. It's the set of instructions that lets all of these thousands of different computers, scattered all over the world, come to an agreement, a consensus, and keep the whole thing secure and running smoothly. Now, to get a handle on this agreement problem, the crypto world first came up with an original and still very famous solution.
And that, of course, is proof of work. You've definitely heard of it. This is the OG system, the one introduced in the original Bitcoin white paper. It was a truly groundbreaking solution for running a network without needing a central boss.
So how does this thing actually work? Well, at its heart, it's basically a giant, super competitive global lottery. You have miners all using these incredibly powerful computers to race against each other, trying to solve a really hard math puzzle. The first one to crack it gets to add the next block of transactions to the chain, and for their effort, they get a reward. This work proves they spent real-world resources, and that means a whole lot of electricity, which is what makes it so expensive to attack the network. And well, that expense is where the trouble starts.
And the cost is just staggering. It's kind of hard to even wrap your head around the scale of it. The Bitcoin network, which runs on proof of work, uses more electricity in a year than entire countries. Yeah, countries like the Netherlands. This has obviously become a massive environmental concern, and it's probably the single biggest knock against the technology.
But it's not just the energy bill. Proof of work also created what people call a hardware arms race. The race to solve those puzzles got so intense that now only huge industrial-scale operations with access to specialized computer chips and super cheap electricity can even hope to compete. This has actually led to the system becoming more centralized, with just a handful of big mining groups controlling most of the network's power. So, all of this, the massive energy use, the centralizing effects, it naturally led the entire crypto community to start asking a really important question. Is there a better way to do this? A more efficient way? And that's where proof of stake comes in. This is the challenger. It's a totally different approach to consensus, designed from the ground up to solve those exact problems of energy consumption and accessibility that we see in proof of work.
Okay, so what's the big difference here? It's simple, but it's a huge shift in thinking. In proof of work, you have miners who compete using raw computing power. In proof of stake, you have validators who compete using their own capital. They literally put their own cryptocurrency up as collateral, and instead of a race, an algorithm chooses who gets to create the next block based on how much they have staked.
This change is absolutely crucial. Security is no longer based on who can burn the most electricity. It's based on an economic stake. You're not proving you did a bunch of computational work, you're proving you have skin in the game. You're putting your own money on the line, which gives you a powerful incentive to play by the rules.
This whole economic model is held together by a really clever system of rewards and, just as important, punishments. Let's take a look at how this whole system of stakes, rewards, and penalties actually works. So, to even get in the game and become a validator on a network like Ethereum, you have to lock up a pretty significant chunk of collateral. In Ethereum's case, that's 32 Ether. By doing that, you're directly tying your own financial well-being to the health of the network. If the network does great, your stake is worth more. But if you do something to harm the network, you stand to lose a lot of money.
And that brings us to the ultimate deterrent. It's called slashing. And let's be clear, this isn't just a little fine or a slap on the wrist. Slashing is a severe penalty, where the network literally destroys part or even all of a dishonest validator's staked coins. It's the ultimate guarantee that cheating is way more costly than any potential reward.
So what kind of behavior gets you in this much trouble? Well, we're not talking about simple mistakes like your internet connection dropping for a bit. Slashing is saved for the really bad stuff, for deliberate malicious acts, things like trying to propose two different blocks at the same time or trying to rewrite the history of the blockchain. It's the penalty for blatant cheating that puts the whole network at risk.
But look, proof of stake isn't a magic bullet. It's an evolution, and like any evolution, it comes with its own set of trade-offs. The pros are huge, right? It's way more energy efficient, and you don't need a warehouse full of special computers to participate. On the flip side, there are real concerns. There's the rich get richer problem where people with the most coins could end up with the most power. There's also some complex theory behind it, and of course it just hasn't been around as long as proof of work, so it's less battle tested.
But even with those concerns, the move towards proof of stake is one of the single most important trends happening in the blockchain world today, and it has massive implications for where all this is headed.
Just look at this number, over 99%. That is the estimated reduction in energy use for the Ethereum network after it switched from proof of work to proof of stake. They called it the merge. It basically took a network that used the same amount of power as a country and turned it into one that uses the power of a small town. It's a monumental, game-changing shift.
And the innovation isn't stopping here. We're already seeing new variations pop up, like Delegated Proof of Stake, or DPoS. This is an attempt to deal with that rich get richer problem. It lets anyone with tokens vote for a smaller group of delegates who then do the validating for everyone. It's an effort to keep things efficient, but also make it more democratic.
So this really is the central question we're left with. Proof of stake has pretty definitively solved the massive energy problem that plagued its predecessor, and it's opened the door for more people to get involved. But as we go forward, we have to ask, does securing a network with capital, instead of with computation, just introduce a new kind of threat? The answer to that is going to shape the entire future of this decentralized world.